Hello and welcome back to the lab. Today on the bench we have an example of a HP model 412A. So a little bit newer than some of the other ones that are running around here on the web. This one, unlike the 410, does not have a vacuum tube in the probe. I don't know if there is anything in here or not, or if this is just it. But we will take a look and see how it goes. In this video, we're going to pop this open, take a look at it, see if there's any components in here that need to be replaced, get this all serviced up and calibrated for the bench. I've been wanting to get some VTVMs for the workbench for a while. Just some things haven't aligned, and I haven't been able to find what I was looking for. But we have a couple that look good. We'll also service up all the contacts, make sure everything else looks good, and then we'll put this into service, fixing some other equipment. So to get into this unit, so unlike modern meters, the leads are permanently attached to the front of this, which is good because you can't lose them, but it's also a little weird because they're permanently attached to the front of the unit. But to get into this one, it's just these two screws on the back, and then it comes apart. This one comes to us from AT&T & Co. Central Office. So that is originally who had this unit, so says the paint markings on the side. Okay, this is kind of wild. We have a Synchron here with 4 bulbs. Let's see what this does. I have a sneaking suspicion that might be a chopper amplifier. And this might be a motor. When I plug it in, we'll have to see. We have a lot of tarnishing down here on this contact, so we're definitely going to need to clean the switches and everything else. A couple of multi-section caps, which we're going to have to deal with. Figure out what a good way to modernize that is going to be. Let's see. What else do we have on the other side? We have one more possibly multi-section cap, maybe a single cap that we will have to deal with. Have some Sprague capacitors back here that'll be cleaned. I have to look up. I don't remember if it's the red ones that have to go or if it's the yellow ones that have to go. But one of these Black Beauty style capacitors is fine to leave in circuit, and the other one is not. So we'll take a look at that. Let me pull this cover off, and we'll take a look and see how much this cap's going to be a pain in the butt to replace. Well, and here I thought this meter repair was going to be boring, but this is the gift that keeps on giving. I have been struggling with troubleshooting this meter for the last couple of hours. It's been doing some really, really squirrely stuff. So I want to show you guys what it was doing. I will break it here real fast. Please stay broken. So we'll turn this on. Oh. Well, I need to change that anyway now that I saw that. Never mind. So this is kind of what it's doing. It's not really connected to anything. It's here's the ohms input. The common's hooked up to the power supply, but the volt input is just floating. And if I let it sit here for a little bit, the needle's going to kind of go bonkers. If I reverse the polarity, it goes back up and comes back down. And it just does some strange stuff. There it goes. And it's going a little bit nuts. So I thought I'd done something in the power supply because this started right as I was finishing up the power supply. I fired it on with the Variac and backup supply. There was nothing eventful. I don't remember if I turned the camera on for that or not, but it started doing this. So I'd also serviced the range switch. See, it's floating. Like, nope, nada. So I thought I broke the meter. Well, what ended up happening, well, the work that was done, do this without getting shocked, was over here. We put these 2 capacitors in to replace that multi-section cap that was right here. Put a terminal tie strip in here, rewired this whole thing. And one cap goes to one of the voltage regulators. The other cap through this 47K resistor comes to this cap now and is the other power rail. This is non-conductive, so I can point around. So, but the unit was kind of out to lunch and was being really stupid. Well, this bulb decided to not light. This is the chopper amplifier. There's a motor in here that spins and cuts light from the other side from the photodetectors, and this was one of the ways they set up a chopper amplifier back in the day. There's another version about this that uses some neon bulbs that Mr. Carlson's lab fought with for a while. I forget which HP meter it was specifically that was in, but it used neon instead of incandescent. Given everything that he had to do, I'll take the incandescent version. It's much easier to find bulbs for those. These are standard 6.3 volt bulbs. These are standard 6.3 volt bulbs, so nothing special about these, except this one didn't want to light. So turned out it was dirty contacts. Pulled the bulb out, put it back in, and it lit up. So that was good. A little bit of contact cleaner fixed that. Because it was going absolutely bonkers on the front end, I hosed the range switch off with alcohol. That's the recommended cleaning from HP in the service manual. I have aerosolized alcohol, and I put the meter over a trash can, and sprayed the switch with alcohol, moved it back and forth a whole bunch of times. I also did check. None of the power rails in this one go over 200 volts, so these 450 volt caps are fine. This is an incredibly high impedance selector switch in the bottom of this. Fingerprints need to stay off it. The input impedance of this particular meter is 200 megohms at the lowest ranges. So you're getting into where the conductivity of a fingerprint starts messing with stuff. So thought it was a range switch that was messing up, sprayed the living daylights out of it, and nothing. So it was still acting stupid. When it finally does settle out, this is what it does. Needle's pegged this way. We'll reverse the polarity. It goes up, but you can see it's kind of vibrating in the picture. So clean the switch a bunch of times. Check the ohms range. Nothing was happening. Check the power supply. Everything looks sane, at least for preliminary checks. So did all the normal stuff. Then I started thinking about it. And the HP manual says if you're having problems with the meter, swap tubes. So I have a stock of tubes, and it turns out I don't have near as many 12AX7s as I thought I did, because when I was testing some of them, I had a whole bunch where the filaments didn't even turn on. So fortunately, we asked the lab to give us something, and it has returned to us a 7025 tube, which is a military-grade 12AX7. So if I pop this HP tube out, so this is an original tube with the meter, been in there for a while, branded HP, 12AX7, ECC83, and we put this tube in. It is off, and I am being very careful not to touch anything that would be spicy. Don't break the pins. Nope. There we go. Okay. So the tube in question, here's our tubes. I still need to figure out what this capacitor does, if we need to go after it or not, but I was just doing a power-up check because I had to rewire pretty much the whole power supply. Voltage regulator tubes, when working on the power supply, I took this tube out, that tube back there to get to some nuts and bolts that are hiding behind there. We also popped this tube out too. Now this tube has a shield over it because it is part of the sensitive measurements. So this pops down like this, rotates, come on, yes, rotates, and then pops back up. And that actually has a spring that shields the tube and pushes it down to the socket. This is a shield plate to shield the range switch from problems. And because I was working on the meter, I had the, whoop, give me that back, that's going to be important. there's this thing that HP gives you, which is a kind of grabby probe. I had common hooked up to the power supply. I was just using the Rigel, and I was putting 2.5 volts into the probe head. Well, let me show you what was happening. Okay, we'll set it positive and turn the power on. We will need to wait for some things to warm up because we are dealing with vacuum tubes. Now it's going to make a liar out of me, which I'm kind of irritated about. Because my meter's saying 2.497, and this is reading 2.49. So I'm really annoyed. This was down here below 2 volts, so I was missing about a half a volt from the meter reading. And just for grins, I took the clamp probe off, and I put the pin probe on, and I found all the voltage back. So what I was going to say was there was some tarnish on the probe head that was causing some of my problems, but clearly that's not the case. I just can't hook stuff up right. Actually, it was probably a very marginal connection on the clamp, and that was what was doing the problems. So I've been chasing my tail for about 2.5 hours. To figure that out, although I was not expecting a toasted tube to be part of the problem, but we did have a toasted tube, and my tube tester, which I also now need to replace a socket on because I tested so many 12AX7s, it did say the 2 triodes that are in here are very out of balance. One of them is way weaker than the other one, so that could be causing some of my problems. So meter's happy now. I'm going to figure out what that other cap does, and then I'm going to... actually, we could check some ranges. Let me hit 30 volts. We'll go up to 30 volts, and we'll do 25 volts on the input. And there we go. 24,996. Not half bad. All right, so I got the chopper working again. That was just a contact. We have a new tube because we did lose a tube on this one, and yeah. Okay, I've pulled one of these Black Beauty caps out of the unit. There's 2 more in there, and of course I don't have the right values in the lab, so I have to wait on the mail guy. 200 working volts DC, and we're running about 13 nanoamps on the source measure unit. Through that, it started at 100 nanoamps, so this one has started to become leaky. The weird thing about this one is it wasn't connected to anything. So when I unsoldered it, I don't know if they're using some leakage from the terminal tie strip down to the chassis or not, but the other 2 caps that are in the line, they're connected. This is only connected on the one side. It's not connected on the far side. So I do not know what's going on there. Everything looked factory. It didn't look like there was a somebody been in here before, so I don't know on that one. But anyway, I'm going to let it run, and we're going to, I'll get some new caps in. I have 0.047 microfarads. I don't have 0.47 microfarads. I will have to pick up some new capacitors. In the meantime, I got the capacitor replaced on the back of the meter. There's a couple more electrolytic caps that I want to get off of that board, get off of the boards, and get them replaced while everything's working. But I was hoping to get this done today, but it's going to take a little bit longer, and that's okay. Sometimes these restorations take as long as they take. Okay, we have pulled out the old Black Beauty capacitors that are 0.47s and a 0.5. I think there were 2. No, they were all just 0.47s, and they were at 200 volts. They were leaky. I've checked for the band end on these new Illinois caps, which are not Illinois caps anymore. Illinois capacitor got bought out. 0.47 microfarad. These are at 400 volts. For whatever reason, when I ordered these, I thought they were at 400 volts to start, so I was going to overdo it. So I almost put 600 volt caps in there, which would have been way overkill. But I've got 3. I'm going to get them in, and then we'll move on to some of the electrolytics and then see how we're going. Okay, for this 50 microfarad by 6 volt, we have complete overkill at 47 microfarad by 35. I had to space the leads accordingly because there's a trace that's going to run through this split once it's on the board, and this will stand the cap off the board. Polarity-wise, it goes in this way with negative going to towards the front of the meter. And here's our capacitor hiding behind the vacuum tube. Incidentally, this was the vacuum tube that actually went bad, and I needed to replace. So this was the 12AX7 that was in there. This is C110, is that guy right there. Now there's one more cap that I want to replace on the bottom side of the meter. So let me flip it over, and then we'll go from there. And here's the cap in and ready to go. This is another bidirectional, or bipolar. At least the service manual for this particular unit called it a semi-polar electrolytic capacitor. So I'm going to leave this one in circuit for now and let that roll. These are all good, high-quality caps. Everything on the range switch is extremely high quality and doesn't need much. The ceramic discs, very little goes wrong with those. So everything is good to go. So I'm going to get the tube put back in, and then we'll fire it up and give it a smoke test. Okay, I am on the monitored and current limited supply in the lab. And so we will go ahead and fire this up. I do have it hooked up to the Rigol for reference, but I haven't actually turned that on yet. Go ahead and kick this on. We are drawing 25 watts. That's plenty healthy. Needle's going to kick over. That's a normal warm-up of vacuum tubes. And let's go ahead and see if we put some voltage to it. I'm on the 30 volt range, so we'll give it 25 volts in the front end and see how we go. 25 on. Very cool. So the meter's reacting very well. We're off, but it was also under 0 too. So that's going to be some bias adjustments and things like that. Changing out those caps definitely is going to need some bias adjustment stuff. So the next step is to put the shields back on, and then we'll run it through its calibration procedure. I was pretty confident that this was going to go relatively smoothly, so I've got the 7510 warming up and the 343 warming up. So I'm going to turn this on and let it warm up for as long as they do, because this needs, I think, a 30-ish minute warm-up time. They need an hour and a half, both. So I do not need to use the 5200A because this is not an AC meter. This is only volts, milliamps, and ohms. But we'll let everything warm up. Turn this off for now, so I can put the put the shields back on without getting shocked, and then it's just a waiting game. Okay, the first thing we need to do on this meter is the mechanical zero of the meter dial, which was actually done, because if I turn this off real fast, we let everything discharge, it will slowly come back to 0. And looking dead on the meter, it is dead on 0. Everything is good to go there. So we have a good mechanical 0. So we'll bring this back up. The next thing we have to do is the hum balance control, which is hiding back here. This can also not be done on a... oh, you can actually see the chopper. I can't see this without looking through the camera, but the shutter and the chopper, you can actually see the chopper amplifier doing its thing. For the hum balance control, we have a scope hooked up to the front end at its most sensitive position, 5 millivolts. And I'm going to move you guys over to the 7603. Okay, so we'll zoom this up. Okay, sorry about the flashing green light here, but you guys have to see it the same way I do, because we are actually looking at a 10 cycle per second chop rate. This is way off, so we're going to tweak this hum balance control for the lowest signal. Now the fuzz on there, and there we, ooh. And if we go too far, it comes back. Now because we replaced that 12AX7, this was a mandatory adjustment that we had to do per the service manual. So the hum balance and the bias, which we're going to do next, is required every time that tube gets replaced. The fuzz here is the 120 cycle per second ripple. The hum balance doesn't do anything for that. It was that larger waveform, the larger waveform that we were minimizing on that adjustment. Okay, so I need to be straight on to do this, so I have you guys off to the side. I need to tweak the bias for the 12AX7 because... oh, wait. I have to set the bias right. Oops. There's a bias mode right here. It's one step. So when setting the bias, you have to come around to the bias mode, which is one step past the 1000 volt setting. So this is 1000 volts. This is bias set point. So bias set point, we're a little high. So we want to bring this down. And this is a very, very touchy control. And it's also, because of the currents involved, it's a slow control to react when you get it close. And this is about as straight on as I can get the camera, but you can see we're dead lined up with 0. Okay, so on this one, the voltage calibration is done on the 1 volt setting. So what we want to do, crank this to 1. And now we're off a little bit. So what we need to do is we need to adjust the gain, R19, or R119, for 0. That is very touchy. Holy cow. Okay, the service manual is very unclear what to do here. But first thing I did was set up 0 the meter to the front with the 0 meter control. The gain control is what we need to adjust, and then meter cal comes later. Okay, it does not tell you to 0 the meter at the beginning of this process, but you do need to do that. We have a very good 1 volt coming out of the voltage calibrator, as checked on the 7510. So what I need to do now is unhook this, because this is only a volt, so we can touch this without worrying about it too much. And then we need to hook up the DC amplifier. We need to hook up the DC amp to the back of or the output of the DC amplifier to the very sensitive meter. And then we need to apply 1 volt to the front end of the DMM. So let me set that up real fast. And we are way out on gain. So now what we need to do is 0 the gain. And this should be done at 1 volt. Well, I'm happy about that. 10 millivolts here would be a 1% error in the meter. So we have it below a 1% error, which is fantastic. And I was going to say we needed to set the meter cal to 1, but accounting for parallax error, we could tweak it a little bit. Not much. It's a little off this way. And that is dead on 1 when you account for parallax error. You can tell there's a little bit of parallax error in the camera because you see the shadow of the needle in the mirror. When you look at one of these, that's what the mirror's for, is you line up the shadow to get rid of the parallax error on the dial face. Okay, our ohms range is off a bit, which is fine. I need to put this on infinity. And I need to make sure none of these leads are connected to anything and we have no leakage paths, because this is a very sensitive meter. The other thing about the ohms range is it's real nice. The adjustment is external to the case, so we could do this adjustment even with the case on. Are we good there? We'll lock that nut down so the potentiometer doesn't move around, and there we go. Okay, I'm going to spot check some currents, and we'll use the source measure unit because I have a dial of current. And what we'll do is we will ask it for 250 milliamps. And we'll say you can put in 5 volts. Oh, wow, I way overloaded that. Oops. It's 0.3 milliamps, not 300 milliamps. I was off by a lot. So 250 microamps as opposed to milliamps. That's much better. That looks good. Actually, that looks real good. Let's go to turn this off. Take it up to 1. We'll do 900 microamps, because it's 1 milliamp. Good enough for 9. And bear in mind, the case is still open. Like we're dealing with the noise and things in the lab and shielding and everything like that. So we're 3 milliamps. So we'll go to 2 milliamps. That's 2. So the current ranges are looking really good. 9 milliamps. And the burden voltages on these is incredibly low. This is 9 milliamps, and the burden voltage on this is 6.7 millivolts on this range. So where you use a shunt resistor, because this has a high impedance front end, the burden voltage on this meter is much lower than the burden voltage on a handheld DMM. Uh, 30. Let's ask for 25 milliamps. That looks good there. And like my burden voltage on this one is 18 millivolts. So very, very low. And let's crank it to the full amp. So 1,000 milliamps, 1 amp, we'll do 950 milliamps. We'll give it all of the beans. And we're very close. I mean, that I asked for 950, and I can't get much much closer than that. So, and my burden voltage there is 500 millivolts at an amp. So, and it's running 0.94996 amps. So, very happy with that. Oh, helps if I turn the output off and don't turn it back on again. So incredibly accurate meter, and very happy with that. One other thing to note is this is the negative supply bulk filtering capacitor, and it only sees 6 to 7 volts negative. So it's a 100-volt cap. It is not stressed at all. Even in operation, it's not stressed. So that one's going to stay, and it's going to be fine. Thanks for stopping by the lab and taking a look at this HP412 VTVM. I've been looking for some needle meters and things like that for the lab for a while, so this one is going to stay with us and will show up in future videos. It's going to find a home somewhere on the bench. I'll figure out exactly where that is, and then we'll get it permanently wired in and set up. As normal, the dish of shame, the bad parts that came out of the restoration. Couple of capacitors, no big deal. The shock was the vacuum tube that didn't end up making it through the restoration process. So I was not expecting to have to replace a tube when I fired one of these up, but it is what it is, and we'll take it as it comes. So, as always, thanks for stopping by. I will see everybody down in the comments, and in the next video. More is always on the way.